Here is a thinking and application problem on rate of change. It says a spherical balloon is being inflated. Find the rate of change of volume with respect to radius when the volume is 36 pi centimeter cube. Now, you should know the volume formula, right? So what is the volume of a sphere? So volume is 4 by 3 pi r cube. Now volume is given to us as 36 pi. So we can write here 36 pi is equals to 4 by 3 pi r cube, right? Now from here we can find the radius r, since radius r is not given to us. So we'll simplify this to find r. So we'll multiply by 3, divide by 4, divide by pi, and then cube root. So we can get 36 pi times 3 over 4 pi. That is r cube, right? Now here 4 goes 9 times, pi and pi cancels. So let me just show this work here. So 4 can go 9 times, pi and pi cancels. So we got 9 times 3, which is 27. So we get 27 equals to r cube, and cube root of 27 is r, which is 3. So we get r equals to 3. Now the question here is, why did we find r, right? Now let's read the problem once again. I should have told you this right in the very beginning. A spherical balloon is being inflated. Find the rate of change of volume with respect to radius when the volume is 36 pi cubic centimeters. But we are not given at what radius. To find radius, we have to use the given volume, right? So volume is given to us, which is 36 pi. From here we find radius. Now we know that we need to find rate of change of volume with respect to radius when radius is 3 or the volume is 36 pi. Do you understand? So that is what the question is. Now instantaneous rate of change will be delta V, change in volume, over change in r, correct? So that is what the instantaneous rate of change is going to be of volume with respect to radius. And here the limit delta r should approach 0, correct? And we are looking for radius of 3 centimeters. So we can write this as limit when volume changes to, so what is the formula for volume? Let's write out. Volume is 4 by 3 pi r cube. So limit when the volume is r minus when the volume is for radius of 3 over r minus 3, where r is approaching 3. So if r is very close to 3, then delta r is approaching 0. So that's the definition which we are going to use to find this rate of change. So we can say this is equal to limit r approaches 3 and volume is 4 by 3 pi r cube. So we'll write down the formula here, which is 4 by 3 pi r cube minus volume when radius is 3, that is given to us as 36 pi, or you can calculate, right? We'll get 36 pi here divided by r minus 3. R minus 3. Well, it was better if we write in terms of 3 itself. I'll show you how. So let me change this. And let me not write 36 pi here. Let me write this formula in terms of 4 by 3 pi 3 cube. So I'll show you how it helps to factor and get the answer, right? So we'll write 3, not 36 pi. Okay, so we'll write 4 by 3 pi 3 cube, right? So I've purposely done this to show you an alternate way of doing. It says limit r approaches 3, and we can take 4 by 3 pi common. Do you see that? This is a 4 by 3 pi is common. And what are we left with? We are left with r cube minus 3 cube. And in the denominator we have r minus 3. Now you can factor r cube minus 3 cube using a cube minus b cube formula. So we get limit r approaches 3, 4 by 3 pi, and that is r minus 3 times r square plus 3 times r plus 3 square, right? A minus b whole cube formula divided by r minus 3, right? Now from here you can see r minus 3 is common factor in numerator and denominator. So we can cancel this. And so we get limit r approaches 3, and we have 4 over 3 pi times r square plus 3r plus 3 square. And now we can plug in r as 3 in our answer and get the answer, correct? So it is 4 by 3 pi, and if I write 3 here, I get 3 square, and then I get 3 times 3, 3 square and 3 square, right? So get 3 times 3 squared, you see? So we get 3 square, which is 9, right? 3 times 3 is 9, and 3 square is again 9. So 9 plus 9 plus 9. 3 times 9, which is 27. Let me write 27. And then we can simplify this and get our answer, which is equal to, let me write here, 4 over, so 3 goes 9 times. Let me simplify this here itself, 9 times, and we get 4 times 9, 36 pi as our answer. Do you see that? 36 pi in this case, and you can multiply by pi and write it in decimal numbers also, but that's good enough. Now this unit is change in volume over change in radius. So that means centimeter cube over centimeter. Do you see that? So that is what we get. So it is 4 pi r squared. Do you see this? 3 square is 9. So you'll notice that rate of change of volume with respect to radius is its surface area at that time, 4 pi r square, right? So that's another question which I've done, which is similar kind, and we want to show you the rate of change of volume in a sphere is always equal to the surface area at that instance of time, right? So that's the answer for us. I hope you understand and appreciate it. Thank you and all the best.